All right, I did leave iPhone Studios around the beginning of 2012. Did 3 years at SchedgeMe, which is doing enterprise scheduling in Haskell on the back end. It still uses JavaScript on the front end, so it's about 50-50 at that shop. But now I've recently released my FRP engine, which is based on my work at iPhone Studios, as well as a considerable amount of work, essentially starting over from scratch many times. And eventually I've arrived at something that I feel is a robust and useful functional reactive programming system. Now, the word that I use to describe it in this title is practical. And I don't mean to create a new category of FRP systems or anything like that. It's not like arrowized FRP. But Reflex is the first system that I've had access to where I've felt comfortable using it for production projects. And so that's really what I mean by practical. So before I get into that in detail, I'm going to start by trying to define functional reactive programming, because that's really critical to any discussion of this, and it really hasn't been defined in a single unified way in the rest of the community. So there are any number of definitions that you might have in your mind that may be completely valid, but this is the one that I use. So when I say functional reactive programming, what I mean is programming interactive systems or reactive systems, depending on how you want to say it, using only pure functions. That is, functions without side effects. So why do we care about this? I mean, I'm sure all of you are experienced enough with Haskell to have a gut level instinct for this, and a lot of you have probably also analyzed it in more depth. But to me, the two biggest things that are important about this are equational and local reasoning. Equational reasoning means that we can change code and be reasonably confident that the new code is equivalent to the old code. We know that because we understand how plus and multiply work, we know that we can multiply by 2 instead of adding something to itself. And we know this because things operate purely. If x were an expression that included a side-affecting function, then we actually wouldn't be able to say this. So if we replace x with I++ in C++, then we're going to end up with a very different result on the left, because x will be incremented twice instead of on the right. And anyone who's done macro programming in C or anything like that knows that this is a common problem when you're trying to change imperative code that has side effects. Local reasoning means that we can understand code without understanding the context in which it's going to be used. And this is really important because we want to be able to reuse code in a lot of different contexts. And the more we need to know about the context in which code is going to run, the less we're going to be able to reuse it in different contexts. So local reasoning means that we can apply this function. We just have to look at its definition, and we don't have to worry about when it's getting applied or where it's getting applied or anything like that. And again, if we have impure functions, they may read, for example, x here may do something or may read out of the environment. And so the result may be different from execution to execution. The result may be different depending on what time of day it is. We can't really know in an imperative language. But if we're in a pure language, then we can look at the function, we can apply it to a sample argument, and know that the result we get is the result we're always going to get. So equational and local reasoning, from a practical perspective, are important because they make our code maintainable and reusable, respectively. Being able to maintain code and change it in ways that we're confident are not going to introduce bugs is critical, because I've seen so many projects where we have developers who are perfectly competent to produce better code or to make code better, but they're too scared to do that because they have certain deliverables that they have to meet, and they simply don't have time to endure the risk of changes they've made that introduce new bugs or regressions or things like that. And local reasoning helps with reuse for the reason I just said, that you can understand it apart from its context. So Haskell has both of these things in spades for batch systems. And what I mean by a batch system is a system that takes its input primarily at the beginning of execution and produces its output primarily at the end of execution. This is why Haskell is so amazing for writing compilers, for writing web servers, anything else that takes a bunch of input, does some stuff, and produces a bunch of output. Now, of course, very few systems are pure batch systems, but still, the more batchy a system is, the better a match it seems to be for Haskell today. Now, that being said, even for writing non-batch systems, I would still write it in Haskell as opposed to pretty much any other language, because the IO monad is my favorite imperative language. However, I lose a lot of the Haskell feeling when I'm in the IO monad or some other imperative EDSL that we've built in this language. So this brings us back to FRP. If we want to build systems that are interactive with all the advantages of purity, then we need to get away from using imperative EDSLs like the IO monad to describe what those systems do. And FRP gives us a semantics to describe what interactive systems do without resorting to EDSLs like IO. Reflex is two things. It is a definition of how FRP should work. That's embodied in a type class that I wrote and documentation that I wrote and will continue to write because it's not quite all there yet. And I'm also working towards formalizing the semantics. And it's also an implementation of that semantics. In fact, it's several implementations, although I've only published the one that works the best. Now, Reflex is built with both GHC and GHCJS in mind. For me, it was really important to be able to build applications that I can make some money on. And these days, a lot of the money is in web interfaces, especially because that's where a lot of front ends are written. And FRP is particularly well suited to GUI programming, although it's very well suited to pretty much any interactive system. One of my friends is using Reflex to build a MIDI synthesizer library. It can also be used for OpenGL applications or anything like that. Basically any interactive system FRP is well suited to, but my initial target was DOM manipulation, and specifically web apps. So I target both GHC and GHCJS. If you build with GHCJS, then you're just making a regular single-page web app or a component to put on a multi-page web app, or anything that you want to put on the web. Compiles down to JS, it manipulates the DOM, and you're good. If you build with GHC, I've integrated WebKit GTK, and so you'll get a native application that runs at native Haskell speed, but uses the DOM for rendering, for styling, and it basically looks identical to what you'll see in a browser, works identically to what you'll see in a browser. That's super helpful because then you can, for instance, debug components of your application in GHCI. You can just take, a text box that you want to check the validation code on, pop it open in a window, test it out by hand. Brings the same kind of interactive REPL-based debugging to GUI widgets that you're used to for command line applications. All right, so now I'm going to get into a particular example of Reflex, show you some of the code, show you some functionality. And because we're looking for something that's really interactive, I chose to build a Twitter front end. And we're going to start super simple. So this is how you make a text box. And when you type into the text box, the text will appear right after it in the DOM. So it's pretty simple. All we do is we make a text area, we give it the default argument, and then it returns a tweetbox variable. And so that's just going to be something of type text area T. T identifies the timeline of the FRP system. You're going to see that in any FRP-enabled data structure with Reflex. You can think of it like the phantom type parameter for ST, if you're familiar with that. But otherwise, just think of it as identifying what FRP system you're using and what timeline you're on. Right now, there's only going to be one timeline for any given application. So we give it the default arguments because there's lots of stuff you can do with a text box. And then later you'll see that we can override certain things, attributes, things like that. Now, once we've got this tweet box, one of the things we can do is we can get the value out of it. And that's going to be a dynamically changing value. And there are lots of different things that have values: text boxes, check boxes, etc. And then we're just going to put that right into this dyn text. And that's just something that takes a dynamic string and draws it on the screen. So the monad here is doing layout. It's not actually very involved with the FRP component of it. This is just like using Blaze or Lucid. The order that you see things is going to be the order they're going to appear in the DOM. And it works exactly like you'd expect. If anyone has questions, feel free to interject at any time. But I think this is a decent stopping point just to see if anyone's unclear about anything. Go ahead.
What is the type of value?
The question was, what is the type of value? Value is a type class function or method that is in the Reflex DOM library. And it basically has an associated type that tells you what the value type of a particular widget is going to be. And it just lets you extract that value. So I just use this to wrap up the common functionality between lots of different kinds of widgets. So for a text box, you're going to get a dynamic string. For a checkbox, you're going to get a dynamic bool. It really depends on the widget, but it'll almost always be a dynamic value. Yeah, it's we're abstracting over this big messy DOM thing, so that kind of stuff is necessary a lot. Yep. Anything else? All right. OK. So now we're going to add an attribute to it. Tweets can only be 140 characters, as everyone knows. So we can very easily enforce this constraint just by setting a max length on the tweet box. Obviously, this doesn't take into account all of the logic of Twitter, but it's close enough for what we're doing. So you can see that this just does that. I assume that's 140 characters. And it's pretty simple. So attributes is another type-classed thing for anything that's going to have attributes. We just use lens here to modify the default value to set the attributes. Now, one interesting thing going on here is we're using const dyn. So the attributes are just a dynamic map from string to string. Regular old data.map.map. We're using this. This is just a little shortcut that I made. This is just an alias for map.singleton. And then const dyn basically says, well, the attributes to a text area are dynamic. You can change them if you want. But in this particular case, we don't need to change them. And so we're just going to make a constant version of that. All right. OK, so now we want to actually give the user some kind of feedback about how many characters they're using. So all we have to do here is basically take this tweet box value, and instead of displaying it, which we're not going to do anymore, we're just going to display the length of it. So first, we map the regular old length function over the value of the tweet box. That produces a dynamic integer. And then we just display that. And display is just the Reflex DOM equivalent of print from Prelude. It just takes anything showable, and it sticks it right into the DOM. Then we can put some static text after that, just to add this word characters. We can wrap it all up in a div using L. So L just takes an element tag name and a child widget, and just sticks it right in the DOM. Question?
So is, I guess, dynamic not a functor, or what is the technique of mapdyn?
Yeah, so mapdyn is just like fmap, except that it runs in a monad. And this is because dynamic values cache their intermediate results. This actually will be changing in a near future release of Reflex. For reasons that I'll get into later if I have time, otherwise we can talk afterwards, the caching action involves creating a state variable, and that's one of the few things in Reflex that requires a monadic context, because basically it needs to know when that cache value is getting initialized. In the near future, I'm going to rewrite some of that code at a lower level so that I can take advantage of a little bit more context that I have implicitly, and then dynamics will be functors. But this is because dynamics are not actually built into Reflex. Reflex has two primitives, events and behaviors, and those ones are both functors. All right, anything else? OK. All right, so now we can take a tweet and we can actually associate a button with it. And then we'll be able to submit the tweet when we want, instead of just collecting the text. So that's going to work like this. Just put in some text, click the button, goes down there. We can put in some other text, click the button again, goes down there. And so here we're going to introduce something that explicitly keeps state, which is called holdDyn. We've abstracted out the display number of characters aspect of this. That's just getting run here now. And we've built this button. So this button with icon function is just another one that we've abstracted out. It uses FontAwesome to add an icon named the Twitter icon, and then it just uses tweet to as the contents of the button. And then that's just going to produce an event of unit. And that event is just going to fire whenever the user activates the button by clicking it or hitting enter or whatever. And then what we do is we take that event and we tag it with the current value of the tweet box. And that's basically going to get, so the value is a dynamic. And that's something that can change and notifies you when it changes. And current gets just the behavior out of the dynamic. And then what tag does is it combines behavior and an event. And as the event's firing, it looks at the current value of that behavior as it passes by, and it just replaces the value of the event. So we have this useless unit in the event. We replace it with the current value of the tweet box, and then we just return that, and it goes into this variable new tweet, which is just going to be an event t string. All right, and then this event, new tweet, comes down here and goes into holdDyn. Now what holdDyn does is it takes an initial value and an event of the same type, and it produces a dynamic of that type, which is going to have the initial value given, and it's also going to change whenever the event fires. The type signature in this overlay is actually wrong, and there's a monadic context around that. That's why we're binding it. So then this latest tweet dynamic is going to come down. It's going to go into this dynamic text, and it's just displayed here. That's pretty much it for this. OK, so the next thing we want to do, because obviously you need to be able to tweet repeatedly as quickly as possible, we're going to clear the box as soon as the user clicks tweet. So I can say 1 tweet, 2 tweet, 3 tweet. All right. So the way this works is that we just take this tweet button event, we bring it up here, we map it so that it just is replaced with an empty string. And here you can see events are functors, so we can just fmap over them regularly. And then we pass that into the set value argument of the tweet box text area. Now, you may be wondering how we've referred to this variable before it's defined. That's thanks to the recursive do extension in GHC. And that's pretty much going to be necessary anytime that you want to refer to something earlier in your DOM than later. And with Reflex DOM, I've spent a lot of time making sure that everything is fully lazy. So you're not really going to have to worry too much about getting yourself into a bind with this. But you know, obviously the standard recursion rules apply. If you define something as equal to itself, you know, you're not going to have a good day. But what I've found is that in practice, it's generally quite safe. Now, another thing that you might notice here is that setValue is an argument to the text area construction function. And that's because in Reflex, as in many other FRPs, the Dataflow rules are completely strict about you know, how data is going to move around. I don't mean strict as opposed to lazy. I mean, if you are sending data to something, it's an argument to that. If you're getting data from something, it's a return value. There's no way to take the return value of this text area and use that to somehow poke at the data in a text box, unless you want to use something that's like an unsafe function that breaks out of the whole FRP framework. But that's never necessary in an FRP program with Reflex. All right, does that make sense to everyone? Question?
So the two things you said at the beginning were that you like equational reasoning and you like local reasoning.
Yeah.
Are you planning to say anything about that with respect to this example, or is that
well, let's see. So the question is whether I guess I have a comment on local and equational reasoning with respect to this slide. So I don't have a specific comment. Do you have a specific question about something that, yeah?
For example, you said you have to, it's on me to reason about the recursive structure of this loop that there isn't an infinite or something.
Yeah.
So now I need some equational reasoning to reason about that, to actually convince myself that if I write this as two separate functions, how do I reason about them to understand that there isn't a, and that seems global to me. Monad fixes it long rather than global.
Yeah, so I think that you have a very good point. This is very similar to the way that strictness is treated in Haskell. I would say that I'm not sure that it violates local reasoning rules, because you can reason about the strictness of an individual function. However, it's not exposed in the type. And this is just like in Haskell. I mean, you can open up the .hi file and get some analysis of how strict it is in its arguments and things like that. But at the end of the day, you're not going to know exactly which arguments it's going to force on a given execution. And that's the same with this system. Now, I would love to have a solution to that, both in regular Haskell and in Reflex. If you have suggestions, I would love to talk to you about it afterwards. But I do know that some people have done some work on this kind of stuff. And if it's possible to add that to type signatures in a way that doesn't get in users' way, I would absolutely love to do that. Go ahead.
So in your slide, in the rec definition, you have tweet box and then tweet button.
That's right.
Why that particular order?
That's because that's the order I wanted them to appear in the DOM. With respect to the Dataflow and application logic, it doesn't make any difference.
So I mean, it seems a little artificial that tweet box comes after your tweet button is being defined after it's used. And so you seem to have mutually conflicting requirements. One is that you want to define tweet button and then use it, but on the other hand, you want it to appear after something else, so it's only because of that it's written that particular order.
Yeah, that's right. But you have to keep in mind that this monad is not doing anything special with respect to the FRP. The FRP does not care at all what order you define any of this stuff in. It is completely lazy with respect to this monad. So the only thing that ordering determines in this monad is layout. And that's just like using Blaze or using Lucid. That's sort of the point of this monad. And it does happen to be the case that some of the primitives, like hold and hold dyn, need to be run in this monad, but they're actually order independent with respect to this monad. They only use the monad to carry a sort of phantom notion of what the current time is. And so you can write stuff in whatever order you want. The FRP will sort it out later.
But if you had chosen a different layout in the opposite order, you wouldn't have needed the rec there.
Well, that's true, yeah.
So, I mean, it seems to be orthogonal requirements that are sort of getting stopping on each other here.
Well, that's true, but I think it's primarily syntactic. I mean, if you want, you can throw a rec all over the place. Like, you can put rec statements as a matter of course in every single do expression, or you can use mdo, which is essentially like that. And for the purposes of this library, it's not going to make any difference. So I agree that it's sort of syntactic noise that gets in there, but I don't think it's semantic noise. I think it's purely syntactic.
So we sidestepped this. Gershon gave a talk here probably 6 months, a year ago about web applications that scale forever. Exact title that he gave. And what we wind up doing in Ermine is we when we have the commentator that introduces that sort of declares the sort of FRP style relationship between here's a button, here's the event for the button, here's the thing that we're going to use to display it. Right. You glue the display in wherever you want in the result syntax tree basically, and use the events to say what portions of the page will be updated. Right. So we split the two rather than have to go into monadic context with sort of rack and do. Let's plumb the two separately and put one above the other without any sort of.
Right, absolutely, and that's entirely possible to do with this. There's one difficulty with that, which is that one thing that I'm able to do using a monad like this is enforce that every widget is placed exactly once into the DOM. The DOM doesn't like it if you try to place something twice, and it might be confusing if you place something 0 times. So I don't know if it's possible to enforce that with another regime.
Linear types.
Yeah. So if we had linear types, then this would be beautiful, and we could do something more monoidal and excellent. But yeah, so that's basically just a trade-off that I made in Reflex DOM, and at some point probably also will implement Reflex Lucid, which will allow you to directly use Lucid syntax with this. But you certainly could, with Reflex and sharing a lot of code with Reflex DOM, implement something that's more like that. And in fact, I do have a function called unsafe place element, which allows you to construct an element wherever you want and then place it into the DOM somewhere. And then it's just on you to make sure that you place it exactly once. All right, anyone else? OK, we are running a bit short of time, so I'm going to try to go through this relatively quickly.
You can go to 8:15. It's fine.
OK, sure.
You don't have to.
All right, thanks.
We run long a lot.
OK. All right, so now we want to get rid of the ability to post empty tweets, because we know that Twitter is going to complain if you try to do that, and we might as well stop you. Now, we're not going to do anything really fancy about that. We're just going to ignore any clicks that you make while the box is empty. And that is just this code right here. So it's ffilter, which is a combinator that I introduced in a type called functor maybe. Now, I would love to refer to another functor, so if anyone has an idea of a functor that allows me to delete elements, that would be great. I'd love to use that instead of my own. But anyway, ffilter is just a generalization of filter, and it will delete anything that is an empty string. In other words, it'll let through anything that is not equal to the empty string. And that's all we have to do to ignore this event and not send empty tweets. All right. So now, if we want to implement our own micro Twitter backend here, we can do that by just changing our hold dyn that we had here into a fold dyn. And what this is going to do is fold our event through time. So just like you have a fold L that will fold from the left to the right, this is going to fold from the past to the future. So we provide our folding combinator, which is just cons from list, our initial value, which is just an empty list, and then whenever a new tweet comes in here, it's just going to be added onto the front of that list. So I'll show you how that works. I can put that in there, and then let's say 1, 2, 3, and you can see that each one just gets consed onto the front of that list. All right, so now let's do the real thing. I'm gonna, let's see. Yeah, I'm going to refresh the page, and then we'll see if I can re-authenticate. There we go.
That's great.
OK, there we go. All right, so now we haven't actually hooked this up to Twitter yet. Have we in this slide? Let's see. All right, so I think that one's just going into the void. But here we go. We can actually make a tweet live. So let's see. And before I hit send on this, let me show you what's going to happen. We've gotten the credentials, and that's just something we've abstracted out. I don't want to go into the details of OAuth implementation here. So that's been built into our widget here. This is the whole widget. The credentials have been produced in the previous slide. And so we just feed that into the widget, and then the widget is going to be able to produce our new tweet. That's going to include the credentials, going to send that into a tweet request. And that's going to go to our server using perform request async. That's an XML HTTP request based widget that's provided by Reflex DOM. And then out the other end, whenever we get the response back from the server saying that we have successfully sent the tweet, it's going to come out there, and then we're going to decode it, and we're going to put it in our last status here. So let's take a look at that. All right, and you can see that there was a little delay there, and that's because it was actually going out to Twitter from this server, posting it, and here you can see I have a live streaming feed from my Twitter account, which is going to appear down here. So, as you can see, I also have the tweet stream here. So does anyone want to help me test this out? If you tweet at Ryan Trinkle, it should show up here. Moment of truth. Not happening?
No one here uses Twitter.
All right. OK, well, really good. Oh, nice, nice. All right. So that's pretty much that. And let's see. So let me explain a little bit about how this widget actually works. Okay. Looks like there might have been some network delay in there, but now we've got the.
It was instantaneous for mine.
Oh, excellent. Yeah, when I'm on a good network connection, this actually is faster than the Twitter GUI. I don't know why that is, but it is true. And these slides are also online, so you can try it yourself and log into your own Twitter account and test my claim there. Okay, so what I'm doing here, I just want to show you how I can actually build this dynamic widget. Basically, we make a div. We can assign it a class for styling purposes. And then we have this thing called simple list. And so you can see that just like before, I'm using a fold dyn to accumulate the tweets, only now they're not coming in just from my tweet box, they're coming in from the Twitter stream. We're using their streaming APIs to get push notifications from them, and then streaming using WebSockets from a server that's running on my machine to this slide. And then they just get accumulated in this list. So then we take this tweets, which is a dynamic list of statuses, and we stick it into this widget called simple list. And what simple list does is it's just going to take a list and blow it out into a whole bunch of different widgets. So we supply a function here, which is going to draw each widget. So T here is going to have the type status, or dynamic status, actually. And so that's just going to be the particular status of this particular element in the list. And the simple list widget is going to handle for us any insertions or deletions that need to occur. Well, as you can see, the program is quite robust. We use types, so things get encoded properly. All right, I've got Anthony Cowley here, good guy. Okay. Oh, and is that Unicode? Okay, I guess Unicode also works properly here. Great. So yeah, basically, we're just drawing each tweet here. We use L-strong to make something bold. Pretty simple stuff. And here we've just added a little bit more formatting. We can make an element with a class that we can use for the font awesome icons. We can use LLI, basically all your standard HTML stuff. Now this is a syntax that I designed to be sort of as close to the basic FRP design as I wanted. And frankly, I didn't want to take on Lucid integration or Blaze integration at the same time that I was taking on the basic FRP implementation. But over time, I and/or others are going to implement, probably Blaze, probably Lucid, anything that we can make fit with the FRP system, because really the specific way that it's entered is not that important. That's something that's more stylistic. And in fact, I've been discussing with several people implementing some templating engine so that you can actually have strongly typed HTML templates that are also FRP enabled. So that stuff's all in the future, but it's all quite possible. All right, so what has actually been made with Reflex? So far, this is pretty much mandatory. We've got a to-do MVC here. Actually, this doesn't seem to be working. I think I disabled this. Let me try refreshing here. OK, so that I think I disabled when I added Firefox support, because it uses web components, and they aren't enabled by default in Firefox. But we do have that to-do MVC example. You can download it. It's on GitHub. It's about 180 lines of code, which I think compares pretty favorably. That includes all markup and all logic. And then we just use the stock CSS file. One of the nice things about Reflex and Reflex DOM is that it puts absolutely no constraints on what you do with your DOM. There are no mandatory IDs, no mandatory tags of any kind. Exactly the DOM you ask for is exactly the DOM you're going to get. because it always uses direct references to the DOM elements for its internal manipulation. There's also an application that my business partner Ali and I built at a hackathon about 6 months ago. This is an application to help lawyers negotiate their contracts. It's basically like the commenting functionality from Google Docs, except that it understands the security and privacy workflows across law firms. So each law firm can have an internal discussion about the document, and then they can also have a public conversation. And everything references a particular piece of the document. So it's just like Rap Genius in that you can select text, comment on it, and then this handles live updating. And this was one of the first serious applications that we built with Reflex. And one of the really great moments in that 48-hour hackathon was that we basically implemented the comment system, and we just sort of implemented displaying the list of comments. And then we realized at that point that we had just implemented instant messaging because everything live updates by default. And that's one of the huge advantages of using an FRP system. Another application that we've built is a courier tracking system. This is basically for the internal logistics of courier firms. Especially, it was built for a particular client which does legal document delivery, so deadlines are incredibly important. If you miss the filing deadline, you lose by default, so your client gets very angry. So real-time updates are incredibly important here. Everything updates in real time in the application, including all the dots on the map, which show where each package and each driver is, and lets you drill down into the actual details of every single job that's in the system. It alerts you when you have jobs that are getting close to the deadline, all that kind of stuff. And again, this is something where having FRP means that we get the right behavior by default. You know, if something changes on the server, if any new data comes in, it's automatically reflected on the screen. Now, that being said, it's very easy to prevent streaming updates from coming in. You can just sort of gate them with a dynamic Boolean or something like that. But it's a really nice default to have for all your data to be correct all the time. Another application that we've built is for Soustone, which some of you may have heard of. They're a company that does a lot of Haskell-based development in the retail analytics space. They're over in New York City. And what we did for them is we rebuilt the front end of their Telescope data analysis application, which is a great application for exploring large data sets. It's backed by AWS and the Redshift database in there. And so it can perform queries on huge amounts of data. But the difficulty is that it's a very complex interface. And for anyone who has built interfaces using the standard imperative techniques, you know, the complexity really grows, and it becomes very difficult to compose different components of your application together because they kind of all work differently once you put them together. And you have to be really, really careful about your state variables, the order they're updated in, and how updates flow through your application. And so we took their front end, which had been written in Haskell using haste, but in a non-FRP style. We rewrote it in FRP, and we were able to do that in just a little over a week, and we halved their code base size while we were at it. We fixed a couple of bugs along the way, and they are now able to iterate a lot more quickly and serve their clients' needs better. Of course, Ali and my company, Obsidian Systems, is we have a website. It's also a Reflex application. It looks just like you see here. And since I made these slides, there is another application that I'd like to show you, which was made by a friend of mine. It's the first Reflex application built that was not built by anyone involved in the creation of Reflex. So let's see if I can load this up here. Not the fastest connection ever. All right. So this is for planning your meals. This guy's a big weightlifter, and so he needs to know how many calories he should be taking in. This app isn't live yet. It's going to be going up within the next couple of weeks. But basically, you gotta tell it how old you are, gender, weight, height. Yeah, the defaults could probably use some work here. All right, I don't think I get the athlete's formula. Let's say light exercise and maintain weight. All right, and so it's already calculated all of these. Let me see if I can zoom out a little bit, because it's really nice to be able to see this update as I do it. So let's say that I were to change my age. Does that make a difference? No, I think that's just for his data collection purposes. Let's see. This one's going to change it. So there. So every time I hit up on this, it's going to update all of those things. Obviously, weight is the most important thing here. And then if I want to, figure out how many of each different kind of thing I want to eat, I can edit the percentages here, and it's going to recompute everything on the fly. So this was really easy for him to write, because the live updating makes calculators like this super simple. He just has to write down the logic, and Reflex handles everything else.
This was also his first app in Haskell.
That's true. This was his first Haskell program ever. So, yeah. Okay, so. And this presentation is a Reflex application. It's built with Reflex DOM, Impress.js, and has a snap-based backend. The Impress.js integration is just about 100 or 150 lines of Haskell. We're using their standard library. I had to make a couple of upstream contributions to make the text boxes work nicely, but it's basically just Impress.js. And so one of the great things about doing it this way is that you can use the plethora of existing JavaScript libraries, at least the ones that you can find that are solid. But it's nice to be able to integrate that and get something that looks really nice without having to learn all of the CSS tricks yourself. So if you're interested in trying Reflex, this is the way to do it. You can install Reflex off of Hackage. Reflex DOM still depends on a number of patches to upstream packages, so I'm not able to put that on Hackage yet. But it is on GitHub. You can get it off of there. And the easiest way to build it is using the try Reflex script, which is going to use the Nix package manager to not only get you the exact environment that I've tested on Mac and Linux, but also it'll get pre-built binaries for you. So instead of a 4-hour build time, including a patched GHC, a patched GHCJS, actually, it's only Cabal that's patched, but anyway, patched build of Cabal and GHC, patched build of GHCJS. That takes about 4 hours. This takes about 3 minutes. So I would definitely recommend this if you just want to fool around with Reflex. Now, since we have a little bit more time, this is normally where I would take a break in the middle of the talk, but this is just a 1-hour talk. So I'm going to just run through a couple of the sort of high-level philosophical and semantic points about the library. So earlier I mentioned practical, and there are 3 key points here. The system needs to be expressive. It needs to be able to write everything that you want to write. It needs to be comprehensible. People need to be able to understand the system and the code you write with it, especially when you're working on a team. And the system needs to be efficient. So practical FRP has to support dynamic data flow. There are some static data flow languages out there, but frankly, I don't see how I could use them in production, because real applications create widgets, destroy widgets, data sets grow and shrink, and I don't think it's possible to do it with a static FRP. And that's not like a special case either. That's the norm. Real applications do that stuff constantly. So it needs to be a serious part of the FRP. So in Reflex DOM, creation and deletion of new widgets is completely supported. It's a very normal thing to do. And you don't have to do any imperative coding to make that happen. Another thing that I think is important for expressivity is not having too much of an opinion on what time is. Reflex's concept of time is just that it is ordered. Any occurrence of an event is either occurring before, after, or at the same time as any other event occurrence in the system, but there's no measure associated with the time dimension. You can't ask how long between two different points. In fact, if you don't receive an event during some span of time, there's no way for you to know that that time has actually passed. So this, I believe, is a weaker conception of time, or more importantly, a more general conception of time than any of the other FRP systems I've seen. Although I've seen some that are similar, but I haven't seen any that are more general than this. And so this would allow both continuous and discrete but measured time systems to be implemented in terms of it. And I think it's really important for FRP not to take too much of a position on what time is, because even in fairly simple cases, like let's say you have a video game where you've got a game clock, and then you can pause the game, but on the pause screen, there's an animation. Well, you've got two different clocks there, and you need to be able to start and stop them independently. And so if you have an FRP system that presupposes a measured, high-level, global clock, you're going to have to do all kinds of weird contortions to implement that scenario. With Reflex, you can implement time just as an event that fires with a clock periodically, or you can do something more complex if you need to. But in that case, you just prevent that event from firing for a little while to pause the game. So it's super simple, and I just wanted to enable as many different semantics to be used as possible. For comprehensibility, I think determinism is an absolute must. I didn't get started on Haskell because I wanted a less well-defined language to work in, and I think FRP should be no different. So in Reflex, all the primitives have well-defined behaviors. And over time, they're going to be increasingly well documented. That's part of the reason I'm working on a formal semantics for this. Go ahead.
If you have deterministic behavior and concurrent events, doesn't that mean that you have to reason globally about whatever the other thing is you're going to use to order the events so that you can evaluate them in order to get a deterministic result?
So I don't think so. Imagine you have a function that takes two events as input, and it has them interact in some way. It only needs to concern itself with making sure that it can handle any plausible interleaving of those events. And how those events are sent to it from other parts of the system will never impact whether those events are simultaneous or not. So in Reflex, the entire system has a notion of a frame. And each frame is a point in the timeline. And all event propagation happens instantaneously within a single frame. So there's never going to be any non-local reasoning required to determine how two events are going to interact. Now, if you're taking two events as arguments, yeah, you're not going to know what sequence of firings they're going to have. But that's the same way if you take an integer as an argument, you're not going to know which integer it's going to be. So that's just part of the value. But as far as I know, and I've used this stuff quite a bit, you're not going to run into any situation where you need to reason globally about the timeline. A third event over here is never going to impact how your two events interleave over here.
That seems like that seems like a very strong standardization model.
It is, yes. And in fact, one of the extensions that I've been thinking about and discussing with people is how to properly do distributed systems with this, because this is too strongly synchronized to implement an efficient distributed system as a single FRP circuit. You can implement it quite easily as a server running an FRP circuit and a client running an FRP circuit, just like I made XHR calls. And Snap isn't even FRP. So you can interact with systems that are desynchronized, whether they are FRP or not. But it would be really beautiful to be able to write a whole distributed system as a single FRP circuit. But that's going to require primitives that allow you to explicitly desynchronize components of the graph. Yeah. All right. So another thing that helps make FRP comprehensible is using idiomatic Haskell. So that includes using pure functions wherever possible, using functor and applicative and things like that. So events, for example, are an instance of the align class. So you can take two events and you can align them and you get an event full of these AB. So if any of you are familiar with the these library, it's awesome. Check it out. It lets you align lists, zip them together. It lets you align maps, and it lets you align events. So out of the 10 primitives in Reflex, 8 of them are pure functions, and 2 of them are monadic. I've messed around with arrowized FRP, and it really gives a lot of power to the implementer, which is fantastic. But as a user, it introduces a whole lot of syntactic complexity. And I found that I was able to get enough power on the implementation side without doing arrowization that I felt like it was the way to go to keep it pure. With respect to efficiency, we need good asymptotic CPU usage for all of our operations. One of the key things is that as the size of your program grows, that cannot cause individual events to propagate more slowly. And this is something that is pretty tricky to get right. But in Reflex, events that are on the other side of your system or pieces of your data flow graph that are not touched by an event will not contribute anything to the cost of propagating that event. And that's really important. Other things that are really important are getting the ability to merge events efficiently without having to actually inspect each of those events. Because you may be merging 1,000 events together, and if you have to inspect every single one of them explicitly, then you end up just sort of reevaluating your whole graph, and then event propagation takes order n in the size of your program. That's horrible. So practical FRP needs to have the asymptotics that you would expect out of everything. All right, I'll wrap it in 5 minutes. OK. And then finally, with respect to efficiency, everything needs to be garbage collected. We're in Haskell. We have garbage collection. This really isn't very negotiable for me. And so Reflex goes through some pains to make sure that everything is fully garbage collectible, including that if you have an event that needs to subscribe to an external event source, it will get initialized and deinitialized properly, so that once your Haskell FRP circuit is destroyed by the GC, external resources will also get released. All right, so I'm not going to have time to go into any depth on the semantics, but we've got events and behaviors. Those are the 2 fundamental types in Reflex. We've got never, which is the trivial event. We've got constant, which is the trivial behavior, which always has the same value. We've got push, which is the ability to fmap from one event to another, as well as reading the current values of behaviors and possibly discarding the value of the event as well. So this is sort of like a superpowered fmap, and the type signature is basically everything that you could imagine doing to map one event to another one. Pull is the equivalent for behaviors. It lets you sample as many behaviors as you want, combine their values however you want, and it'll cache the result into a behavior. We can merge many events together. This is a pretty hairy type signature here, but basically what it's saying is you can take a dependently typed map with however much stuff you want in it, of whatever types you want, and it'll merge it all together into an event with a DMAP inside with all of the currently firing occurrences of the event. So if you have many occurring simultaneously, those will all be represented in the result. This is the primitive merge. There are many merges defined in Reflex that are simpler than this, like align, for example. But this is sort of the low-level one that does all the heavy lifting. We also have fan and select. This one basically just takes one event and distributes it to many, many listeners in a very efficient way. It doesn't have to go through every single listener and figure out which ones are subscribed. It uses an index internally to only distribute it to interested listeners. Now we have our higher order combinators, switch, which takes a behavior with an event inside and always listens to the currently selected event, just producing an event as the output. And we also have coincidence, which is much less often used than most of these other ones, but it basically diagonalizes an event of an event. In other words, it fires the output event whenever the input event is firing and the event that it is firing with is simultaneously firing. This isn't needed all the time, but there are a few places where it is needed. It is needed for Turing completeness, and basically that's what it's for. Go ahead.
Does this make event a monad?
No, actually, because there's no way to write return for events. There's no way to generate a occurrence of an event without receiving one, unless you are outside the FRP semantics in FFI land. And then we have the two monadic operators, sample, and sample gets the current value of a behavior. You're allowed to do that inside of another behavior or inside of an event. And then we have hold, which allows you to build one of those state variables that you saw in the earlier examples. And that's only allowed to be done inside of a firing event. All right, and I'm going to skip over the rest of these slides, but let's see. You can find it all on GitHub, and you can find some of it on Hackage, and it'll all be on Hackage soon. Thanks. Go ahead.
Is this presentation itself on GitHub?
The presentation is not on GitHub, but it is on the web. I can give you the URL. You can post it to the group afterwards, maybe.
To get to the source of it?
The source is not up right now. It will be up soon. Yeah, it needs some cleanup, but it will be up soon. And also, Reflex Impress.js will be released as a separate library, possibly even sooner than that. Go ahead.
How hard is it to write the bindings to like the DOM that you wrote for my own stuff? If I have my own events that I need to wire into your system.
Yeah. So I have an example for generally wiring Reflex into things. Let's see. And so this is about this much code. Most of that is comments, so it's about 30 or 40 lines of actual code. That is a simple Reflex framework for writing very simple command line apps. So your application just gets an event with a character inside, and it produces a behavior with a string inside as the view of the application. And so this is a tutorial for how to write your own Reflex integrations. The DOM is a really hairy thing to work with. So that one is pretty complex. But integrating with more sanely designed libraries would probably be a lot easier. Go ahead.
Could you talk a little bit about so GHCJS, like how do you control or even reason about the executable or not? I mean the amount of JavaScript that's actually going to end up on the client. Have you found it to be a problem? And I guess how do you?
Well, it's something that you have to keep in mind. Lauta has done a ton of great work to reduce the output size recently, but it is still on the large side. This talk with minified and compressed JS has a little under a megabyte of client-delivered JS. That's not ridiculously huge. A lot of web applications I've seen that include jQuery and a couple of other libraries get right up there as well. But if you're loading a page where load time is incredibly sensitive and you're maybe serving to mobile as well, yeah, that's going to be tough. One of the great things is that Reflex DOM runs both in GHC and GHCJS. So one project that's in the works is doing doing server-side rendering of the initial DOM layout, and then your web server could just send the initial DOM. The user would have a fully built page, and then it would just take a moment to become functional. When the JS loads. Go ahead.
So I've seen you've got a fold and you've got switching. So there's some danger that you've got time leaks in an FRP system as well. That was my understanding. Do you have clever tricks for getting around time leaks? Is it possible to write time leaks, or is that something?
It is possible to write time leaks. However, there is nothing inherent in the FRP that causes time leaks. It's no easier to write a time leak with Reflex than it is to write it with an IO ref. Basically, if you have something that's going into a hold and you don't plan on evaluating it very frequently, you should probably use something to make it strict. And you can use that push monad. If you're using a fold dyne, you can use a strict application of your combining operator. Whatever you need to do is totally possible. In practice, I haven't actually seen any time leaks in any of my applications, and I haven't been especially careful in client code about it. Under the hood, all of the Reflex implementation code is pretty careful to be as strict as possible while being at least as lazy as you need it to be. All right, is that it? Great. Well, thanks everyone.